Hello everyone, welcome back to the page. Today we are going to show you an interesting repair tutorial. Do you have a home speaker that suddenly stopped working for no obvious reason and never turned on again? The reason behind this problem is much simpler than you might think. In this tutorial, we will show you how to repair a home speaker that does not turn on at all. First, we will test the speaker. We connect it to the power supply and try to turn it on using the power button on the front panel. As you can see, the speaker does not turn on. These speakers usually also have a main power switch on the back, so we turn that switch on as well and test it again. As you can see, even after doing this, the speaker still does not turn on. This means that power is not reaching the speaker's power circuit, and there can be several possible reasons for this issue. In this tutorial, we will check all of these possibilities together. These speakers usually have a fuse on the main power line, which can sometimes burn out due to the voltage fluctuations. First, we need to open the fuse compartment on the back of the speaker and make sure that the fuse is still working. Make sure to disconnect the speaker from the power outlet before opening the fuse compartment. After opening the fuse compartment, we hold the fuse with two clips. Then we set the multimeter to continuity test mode and check the fuse using both probes. As you can see, the multimeter makes a beeping sound, which means the fuse is healthy. So we put the fuse back in its place and close the compartment. Now we need to open the speaker and move step by step through the internal components to find the actual problem. There are several screws on the back of the speaker. We remove all of these screws to gain access to the internal parts of the speaker. After removing all the screws, we pull the back cover outward to separate it. As you can see, inside the speaker, there are two circuit boards, the wiring, a transformer, and a subwoofer. These home speakers usually use two main circuits. One is the power circuit, and the other is the amplifier circuit. Now we need to remove the transformer, which is attached to the body with two screws. We remove the screws to release the transformer. Now we need to find the fault. First, we have to determine whether power is reaching the power circuit or if the transformer is completely unable to provide power. As you can see, the wiring looks fine and there is no visible breaks or disconnections. Now we inspect the circuit boards to see if there is any sign of burning or any visible damaged components. The circuits also appear to be in a good condition. So we start our inspection from the transformer. Now we need to test whether the transformer is producing output voltage or not. We carefully disconnect the transformer connector from the circuit board. As you can see, 2 yellow wires and 1 black wire are connected to this socket. The yellow wires are usually the positive outputs, while the black wire is usually the negative or common connection. Now we check the information label on the transformer. This transformer has 2 outputs, 10 volts and 2 amps. The term Vx2 here indicates that this transformer has 2 separate outputs. Now we need to check the transformer. We secure the connector in one position using a clip so it does not move during testing. Then we set the multimeter to AC voltage measurement mode and select the 20 volt range, because the 10 volt output is within the 20 volt range. Turn on the power button and then check both transformer outputs using the multimeter probes. Make sure that the red probe of the multimeter is connected to the positive wires, which are the yellow wires, and the black probe, which is the negative probe, is connected to the black wire. As you can see, no voltage is shown on the multimeter display. This means that the transformer is not supplying any power to the circuit. Transformers usually stop working for 2 main reasons. The first reason is a burned internal winding, and the second reason can be a blown thermal fuse, which is usually installed inside the transformer. The thermal fuse is normally located inside the lower layers beneath the wrapped insulation of the transformer. Therefore, we first need to remove the metal protection cover and then carefully open the wrapped layers to access the thermal fuse. Keep in mind that the thermal fuse is usually placed on the input side of the transformer, not the output side. In other words, it is located on the side with the red wires, which you can see on the other side of the transformer. To make it easier to work on the transformer, we first disconnect the woofer connectors and the front panel buttons, allowing the circuit section to be separated from the woofer enclosure. As you can see, I carefully cut open the input side of the transformer to reach the thermal fuse. The thermal fuse is usually placed in series with one of the input wires and the transformer winding. Its job is to cut off the current if the transformer temperature rises excessively due to a short circuit or an internal problem, preventing damage to the circuit. The thermal fuse used in this transformer is rated at 130 degrees Celsius. Now we set the multimeter back to continuity test mode to check whether the fuse is still working or not. If the fuse is healthy, the problem is most likely with the main winding of the transformer, and the transformer must be replaced with an identical one. As you can see, the connection through the thermal fuse is broken and the multimeter does not produce any sound. This means the transformer itself is fine, and only the thermal fuse has failed due to the excessive heat and needs to be replaced. I could not find the exact same model of this fuse, but these types of fuses are also rated for 130 degrees Celsius. Now we need to install the new fuse. Keep in mind that you cannot solder the thermal fuse directly, because the heat from the soldering iron can damage it again. Instead, the wires must be securely connected to the fuse, and the connection area should be insulated with heat shrink tubing. This process needs to be done very carefully. After finishing the repair, we place the open parts of the transformer back over the fuse and secure them in place with electrical tape. Then we reinstall the metal cover of the transformer. Now we reinstall the transformer in its original position using the screws and reconnect all the connectors that we previously disconnected. After completing the repair, we place the back cover of the speaker back into its position and tighten all the screws. Now we connect the speaker to the power outlet, and as you can see, the power light turns on. We were able to bring this speaker back to life with the lowest possible cost. Now let's test it. As you can see, the speaker is working perfectly again. I hope you enjoyed watching this video. If you found this tutorial helpful, make sure to like the video and follow the page for more repair tutorials. Also, we would love to hear your thoughts and experiences in the comment section. See you in the next tutorial. Goodbye.